part 3 of the RatRig V-Core 3 Core XY Premium 3D printer build. Today we complete the wiring, set up Klipper firmware, and bring the beast to life. This video deals with mains voltage wiring, which has the potential to kill. This is not for beginners. Please consult a professional before attempting these procedures. We're back with part 3 of this awesome 3D printer build, the premium quality RatRig V-Core 3. In parts 1 and 2, we completed all of the mechanical build, and today we are completing the wiring and setting up the Klipper firmware. Like last time, I'll respond to some frequent feedback and questions from the last video, starting with how much my build actually cost. That's a great question, and when everything's finished, I'll add up the price and I'll include it in one of the videos. For now, however, let's get into the wiring. I mentioned in one of the earlier episodes that I didn't get my electronics from RatRig and instead sourced them locally. That was in fact from Smash Gadgets, an online store started by one of my patrons, and as the flag implies, it's based in Australia. As you can see, they sell Arduino, Raspberry Pi, and most importantly for me, Big Tree Tech products. This is where I got my SKR Pro version 1.2, complete with TMC 2209s. So job number 1 was to get out these and all of the other electronics ready to mount to the machine. You might remember back in part 1, I fired up the Lowrider 2 to cut this custom electronics panel from black acrylic to take an SKR Pro as well as a Raspberry Pi. However, before mounting the main board to this panel, I followed the instructions on the electronics page to prep the stepper motor drivers as well as the jumpers on the main board. For the X and Y drivers, that meant cutting off the lower portion of the center diagnostics pin. This is only because I'm not using sensorless homing and it will be left intact if you were. As for the jumpers, I simply followed the diagram on the page, with the final result being only the left-hand jumper in place to activate UART for the TMC 2209s, 2 red jumpers in place for the middle stepper motor port, and the other red jumpers left in their default positions. I'm pleased to report that the position of the mounting holes I modelled was spot on, and I was able to mount the SKR Pro as well as the Raspberry Pi using the included M3 hardware and standoffs. Mounting hardware for other components, however, was not supplied, so you're going to need to supply your own M4 nuts and bolts for mounting the power supply and the solid state relay. With everything bolted on, this is what it looked like, and we were ready to start wiring everything together. My last video was actually designed to support this one and went through all of the common crimp connectors you'll find on a 3D printer. It has instructions on how to use each one and purchase links if you want to get the tools and connectors yourself. So back to the electronics page for the wiring diagram. It's quite comprehensive, and the only piece of advice I have is to open the picture in a new tab so you can zoom right in and get the exact details as you need them. I started by crimping fork connectors to complete all of my high current and mains wiring. When all of that was done, it looked like this, so here's my wiring diagram. RatRig don't supply a mains wiring diagram, so here's my attempt, but please do pay attention to the warnings and disclaimers. On the left of the diagram, we have a fused mains inlet plug, and we can see that outputs active, neutral and earth into the power supply. And then we have a second fork terminal with the 3 wires coming back out for the heated bed. The earth shown here in yellow and green actually goes straight to the underside of the bed plate. It's bolted to the bed plate with a ring terminal and acts as a grounding point for additional safety. The neutral goes uninterrupted to one of the mains input wires for the bed, and the live goes through the solid state relay, which the main board uses to switch the heater on and off. As for the other wiring, a loom came for each of the end stops. However, to match the diagram on one end of each, I had to switch the red and white wires. That made it match the wiring diagram on the RatRig website, which is correct. When I ordered the kit, I opted to get the optional stepper motor wires, which have the correct plug for the stepper motor on one side, but a generic DuPont connector on the other. There's 3 short wires and 3 long ones. They were all too long for the 300mm version of the printer. So what I did to get the correct length was to plug them in on each end, route them around the machine, cut off the excess, crimp on a proper JST connector. That gave me a much more appropriate length, as well as the proper connection with the SKR main board. To cleanly pass some of the looms from the front of the printer to the electronics panel, I bought these grommets. They needed a 14mm hole in the acrylic, which I made with this step drill, and I designed and printed this simple jig to help me drill the holes in the right place. For the Y-axis end stop, it slides up against the corner bracket. We get the hole started on the step drill, remove the jig, and then expand it up to 14mm. Install the grommet, feed the wire through, and it all ends up being pretty tidy. For the Z-stepper wires to get from the front to the back, the jig inverts and rests against the center Z-stepper bracket before starting the hole, removing the jig, and opening it up from the rear where there's more room for the drill to fit. Due to the opening being tight, it's necessary to feed the stepper plug through the grommet first, before then installing the grommet in the back of the panel. To help tidy things up, I found this 3030 cable clip holder on Thingiverse, printed out a bunch on my Ender 3, and used them around the base of the frame to hold the loom for the stepper motors out of harm's way on the edge of the machine, where all three feed through the same grommet just underneath the mainboard. I also designed these simple printed wire holders that are mounted on the existing electronics panel bolts and further constrain the cabling to keep everything neat. Now onto the wiring from the Ever carriage back to the mainboard, and there are a couple of cable chain mods available, but instead I decided to remix either end of the cable ties, adding in this cutout to take a spare piece of PTFE tube. After bolting them onto the printer, I was able to squeeze in the tube and form a nice gentle curve, guiding the wires to the print head, which was at its furthest away position. I had a long BL Touch extension cable, so it was just a matter of running that back, cutting it off at the correct length, and then crimping on a 5-pin DuPont connector to suit the SKR board. The X end stop wire was already the right length, however the wires for each fan were way too short, so I crimped on these inline JST RCY connectors to extend them back to the main board. If I have a busted fan in future, this will make changing it really easy. The wires for the Orbiter's stepper motor were way too short, so I had to cut and solder on some extensions back to the main board with the JST plug and matching the colours for the other steppers. For the heater cartridge and thermistor, there are spots to cable tie these neatly against the side of the Ever carriage, which means with everything being the correct length, I can now use a spiral wrap to hold everything together against the PTFE tube all the way back to the main board where cable ties were used to strap everything down. One other thing that I did was use a cheap labeling machine to make a label for each connection on the wiring diagram. It acted like a checklist, and it did help plugging everything into the correct place. That's my wiring done. There's some bits I'm really happy with, and other bits I'd like to put more time into tidying up, but at least for now it's entirely functional. While I still think the mechanical aspects of the assembly were just a long list of ultimately simple steps, I think this wiring has offered a definite step up in terms of the confidence and tools required. Setting up the firmware also had the potential to be quite complicated, but the developers have done a great job in setting up a user-friendly package. The firmware in question, well, that's Klipper. Kliper is an interesting firmware that has grown massively in popularity since I made a couple of videos on it back in 2019. In case you didn't know, here are the basics, and we start with our regular setup, where we have a main board with firmware on it, typically Marlin, and it processes G-code and controls the hardware to make movement and extrusion that forms 3D printing. Often people like to add a Raspberry Pi with Octoprint, but it's separate to the firmware and acts as a host controller, sending requests, but all of the processing is still done by the Marlin firmware on the main board. Kliper is different in that the main part of the firmware now resides on the Raspberry Pi, where its grunt is used to process all of the G-code and send simplified commands to the main board, which then still controls the hardware to complete our 3D printing process. So why would we do this? There's a long list of features on this page that you can read, but I'll summarize the most important ones, starting with the performance and precision of the stepper motor movements. As we can see on this table, our Big Tree Tech SKO Pro mainboard that we're using will be able to process hundreds of thousands of steps per second. And for me, that's going to equal a lot of performance when we set up things like pressure advance, and most importantly, input shaping, which will be the subject of the next part in the series. Other people also like the simple configuration file, where all of the parameters of our printer are listed in a single file, and after we make a change, we simply restart the system, which means no more compiling and flashing firmware. So what's changed since I first covered Kliper in 2019? As you can see in this diagram, the Raspberry Pi not only ran Klipper, but could also run Octoprint, which when combined with the Clipper plugin, gave us easy access to Klipper specific features and configuration. Instead of running Octoprint on the Pi these days, we have specific software such as Fluid or Mainsail, purpose-made for Klipper. Each of them have attractive graphical user interfaces with convenient management of the Klipper configuration files. Klipper has always been a way to squeeze great performance out of an old 8-bit board, but we're using a really powerful 32-bit board, and we're pairing it with an amazingly precise and capable printer. This means our performance potential is crazily high. In the comments section of the last video was a fantastic debate about venturing out into uncharted ground with Klipper versus the tried and tested Marlin. So the question begs, why Klipper instead of Marlin? Firstly, I love Marlin, and without it, honestly 3D printing as a hobby would be nowhere near as advanced as it is. Myself and many others in the community owe the developers of Marlin quite a big debt. However, this build is about pushing the envelope, about pushing for maximum performance, and Klipper has some features that Marlin just doesn't have at this stage. Hopefully its full potential will become more clear in a future episode. As for now, however, let's get it configured for this machine. RatRig also supports RepRap firmware, but we want Klipper, so we're going to click to scroll to that section. And there's a link that we follow through to GitHub where we need to download two files, firmware.bin and vCoreOS. The first thing we'll do is retrieve the SD card that came with the main board, and we're going to put that into our computer and copy over the firmware.bin file. We now put the SD card back into the main board and power it up, which will automatically update the firmware on the main board to that component of Klipper. To verify that this worked, we can remove the SD card, pop it back into the computer, and we should only have a firmware.cur file. The second vCoreOS file is also going to go on an SD card, but this time inside the Raspberry Pi, and we need to use something like Win32 Disk Imager to complete this, making absolutely sure we have the right drive selected, and after around 10 minutes this will be done. On a Windows computer, a drive should come up called boot, and in that is a vCoreOS WPA supplicant file. As instructed, don't use WordPad to edit this or you'll corrupt it. I'm using Notepad++, which is one of the recommendations. Our task here is to set up our Wi-Fi. To do this, we're going to delete the hashes at the left of the line, and then come back and substitute in our Wi-Fi SSID and our Wi-Fi password. Further down the file, we also need to input our country by uncommenting one of the ones there, or in my case, adding it if it's missing. We save the file, eject the SD card, and then insert it into the Raspberry Pi before finally powering it up. Wait a few minutes for everything to install and settle, and then we can access the firmware in our browser by using vCoreOS.local. As you can see on the main interface, we have all of our manual printer controls, but I started by going up to settings, giving my printer a name, and then scrolling to the software update section and updating the components one at a time. Some of these took seconds, some of them took minutes, but overall it was really easy. When they were all done, I took the time to browse the rest of the settings, where I saw I could set up things like webcams, macros, and user presets. It's all intuitive and easy to understand. Exploring the interface, we have a Jobs tab, which of course is empty for me so far, and that goes the same for the History tab, because I haven't printed anything yet. We have a Tune tab for things like ABL meshes, and then we have a System tab, and that's where we find our main Klipper configuration file. As you can see, everything is already set up for this printer, and that's a good thing, because if we click on the config reference, it's a really long and detailed document from Klipper, so doing this from scratch would be quite a daunting task for anyone new to Klipper. Back in our pre-made configuration, we'll notice that other files are linked to from the main one. We can see that we have a file to set up the vCore 3, another one for the steppers, and there's plenty more of these below. If we navigate to the vCore 3 folder, we can see all of the files available and the configurations for our relevant hardware. So far, stupidly easy to get going. But remember, this machine has user customization. So how does the firmware account for this variation? We can see in this folder we have configuration files for the various hardware options, such as the Orbiter and Hemera. So what we do is scroll to that section in our main configuration file and substitute as necessary. The default E3D V6 is good for me, but I'm not running a Bondtech BMG. So all I do is delete that and type in Orbiter, and now I'll be linking to that file. Click Save and Restart. The firmware reboots and is now correctly configured for my specific choice of hardware. So let's say you were building the 500mm version instead of the 300. All you would need to do is go into the configuration file and correct the links and values, save and restart, and you're good to go. Well done to the RatRig developers for making this so easy. That's the base firmware installed, but we still need to go through and double check everything is working as it should be. This page from Klipper, which is linked in the description, will give you a checklist of things to go over. It is written for Octoprint rather than Fluid, but that doesn't really matter, we can still follow it step by step. It covers things like turning on the heaters to a low temperature and making sure that the correct one rises and then falls when you turn it off, and I did this for both the heated bed as well as the hot end. I also took the time to test things like the fans, with the hot end fan coming on automatically and the part cooling fan coming on when instructed. I also did the equivalent of an M119 in querying the end stops, which were all open, until I manually pressed them, repeated the command and got the desired result. Next I turned my attention to the heaters, starting with a hot tighten of the nozzle. I then did PID tuning of the bed. When this was done, you can click on Save Config to put that into the terminal input and then click Send to save and restart the firmware. I then repeated the same command except for the extruder with a higher temperature. The same process takes place, the heater cycling through on and off stages before the PID parameters are given, and we can again save the config. With the nozzle still hot, I then tested the direction of the extruder stepper motor with a manual extrude command, but it was in reverse. Just like with the other axes we needed to reverse, I copied the pin into my main configuration file, inverted its direction, restarted, and that got everything working as it should. Z offset for the BL Touch is pretty straightforward. We home the machine, put a piece of paper underneath the nozzle, and then manually move down in tiny steps until the paper is grabbed. Back in the terminal, we can find out our current position, for me -1.7, so we come into the printer configuration file and change the Z offset to +1.7. Save and restart, and we're finished working our way through the list. That was all of my basic checks out of the way, which meant I was finally ready to test the kinematic bed, and this was a topic which yielded many questions in the last video. Starting with, why are there only 3 mounting points? Well, that's because a plane only requires 3 to be constrained, and you can demonstrate this quite simply. If we have a single point for this plane, we can see it has a large freedom of movement. We add a second one, that becomes more constrained, add a third, and it's not going anywhere. Another common question was, why does this machine have a kinematic bed? Well, fortunately, RatRig have actually answered that themselves. You can pause the screen if you want to read it in detail, but to summarize, it accounts for thermal expansion, allowing the bed to remain flat as it expands from being heated, and it also allows for some pretty nifty auto bed leveling. How about we now demonstrate exactly how that works? Here I'm starting with a level bed, and then I'm purposely skewing it by twisting the stepper motors. We've got a slant from side to side as well as front to back. After homing the machine, we can then issue the Z tilt adjust command. The carriage will then move to 3 specified points from the firmware that correspond to the mounting points of the bed, using the BL Touch to probe them and work out their height relative to each other. What you're seeing is in real time, which means each measurement pass takes around 15 seconds. At the conclusion of the probing is where the magic happens. The firmware calculates what needs to change and adjusts each of the stepper motors individually. It then goes around probing the 3 same points again, double checking the measurements. It made one more fine adjustment in this example before triple checking and finding that everything was within tolerance. Afterwards in the console, we can inspect the results, and we had a range of almost -3 to almost +10. Then Kliper adjusted the 3 motors, probed again, and you can see there's a lot less variance this time. One more round of adjustments, and that gave us a range of 0.01 millimeters. A perfectly flat bed in around a minute that started around 13 millimeters out of whack. And if the bed starts closer to being level, the whole process is much faster. So let's utilize this feature and do our first test print. One thing with this printer is that I couldn't find any pre-made slicer profiles, so I started with a generic one in Simplify 3D. Slicers aren't particularly fussy over the type of printer they're controlling, so all I had to do was name it and then match the build volume before going through and double checking other settings. I actually changed very little here, leaving the default 1mm retraction in place, instead tweaking things like temperature and the amount of perimeters. One thing I did do was add Z tilt adjust after G28 in my start G code to do the leveling procedure. I then visited the Jobs tab to upload my slice G code and started the print job. After homing, the Z tilt adjustment did its thing, requiring one pass to measure and then a second pass to double check. From the start of homing to the first plastic being extruded took just about 1 minute. The Z offset looked to be spot on and the print started without any dramas. So I took the chance to inspect the web interface mid-print. We have a progress bar up the top, and then we have manual overrides for things like flow rate, speed, fans, and even limits for top speed and acceleration. Half an hour later, the cube completed without any dramas. My first print was out of the way and it was successful. This is a nice print with a perfect first layer, crisp details, perfect layer stacking, and no ringing or ghosting. A simple first print, but executed very well. And this is despite doing the minimum. I haven't done any slicer tuning, I haven't calibrated E-steps, flow, I've got the default pressure advanced value, I don't have any input shaping. Honestly, I haven't even tensioned the belts evenly yet. The next episode is about dialing all of these little things in to get the most out of this machine, but before then, one more question. One comment I saw a few times was, what display can be used with this printer? Kliper is compatible with traditional LCD interfaces with a full menu system and control of the firmware. However, I have this Android tablet whose battery is busted but otherwise works well if it's plugged in, and using this, my aim is to have the full web interface sitting right in front of the printer. Custom holder imminent. A humble start, but so much more to come, and I hope you join me next time to see how this accelerometer is going to help hopefully eliminate ghosting. Also, get your questions and feedback in the comments below so I can address it in the next episode. Thank you so much for watching, and until next time, happy 3D printing. G'day, it's Michael again. If you like the video, then please click like. If you want to see more content like this in future, click subscribe and make sure you click on the bell to receive every notification. If you really want to support the channel and see exclusive content, become a patron. Visit my Patreon page. See you next time.